All right, clinicians, welcome. In this series, we're going to break down a really important vestibular monograph that deals with balance assessment. Our goal is to boil it down into the key insights that you can take straight into your practice. So let's kick things off with our first topic, the neural architecture of equilibrium. We're going to explore the fundamental anatomy and the reflexes that really form the bedrock of our sense of balance. Now, just to set the stage, this is video 1 in a 6-part series. And honestly, it's the foundation for everything that's going to come. The concepts we lock down here are absolutely crucial for understanding the clinical tests we'll get into later. You know, the first thing to really wrap your head around is just how ancient the vestibular system is. It's been evolving for an incredibly long time, and its design is built on a clear phylogenetic hierarchy. And if you can grasp the structure, it unlocks everything else. So what exactly is this hierarchy? Well, think of it like this. Way down at the base, in the brainstem, you've got these lightning-fast, hardwired reflexes. Then, layered on top of that, you have the cerebellum and the cortex, providing all the sophisticated adjustments, the learning, and the fine-tuning. It's just a brilliant design, right? You get speed when you absolutely need it, with this layer of smart control right on top. And this whole design, this ancient architecture, it's all built on a set of core reflex arcs. I want you to think of these as the system's non-negotiable hardware. They're responsible for our most basic but most critical functions, gaze and postural stability. So we're really talking about 3 main players here. First up, the vestibulo-ocular reflex, or VOR. This is what keeps your vision stable when you move your head, so the world doesn't look like a shaky cam video. Next, the vestibulo-ocular reflex, the VCR, which uses your neck muscles to keep your head stable. And finally, the vestibulospinal reflexes, the VSR, which make all those tiny, rapid adjustments to keep you from falling over. Now, that last one, the VSR, that's a big one for us in the clinic. It's so fundamental. So let's dig in a bit deeper. How exactly does it work to keep us standing upright against the constant pull of gravity? And what's really fascinating here is how the VSR splits up the job. You have the lateral tract, which I want you to think of as our anti-gravity powerhouse. It comes from the lateral vestibular nucleus and travels down on the same side, ipsilaterally, to fire up the big extensor muscles in our trunk and limbs. That's what gives us the raw strength to stand up. The medial tract, on the other hand, is more of a coordinator. It starts in the medial nucleus and goes down on both sides to sync up the movements between our head, neck, and upper body. So you've got one for raw power and the other for coordinated control. A perfect team. Okay, but here's the thing. These reflexes aren't just firing off into the void, right? The brain has to take these vestibular signals and blend them with everything else it's hearing from our other senses. And this all happens in some key integration hubs. So where does this all happen? Well, the main processing centers are, first, the vestibular nuclei in the brainstem. That's kind of the first stop. Then you've got the cerebellum, which acts like a master editor, comparing signals and filtering out noise. And finally, you have areas in the cortex, like the PIBC, that give us that conscious feeling of motion and our orientation in space. And if you look at where the cerebellum is, it's no accident it's tucked right behind the brainstem. It's in the perfect spot to grab that vestibular information and immediately influence our motor commands. It's essential for fine-tuning our balance, and this is huge for us as clinicians. It's the place where the brain learns to compensate after a vestibular injury. Now, if we zoom in even closer, we find the flocculonodular lobe. You'll also hear it called the vestibulocerebellum. This is the most ancient part of the cerebellum, and it gets a direct, unfiltered feed from the vestibular nerve. Its job is super specific. It processes signals to make little adjustments to the VOR, and it helps the brain figure out the difference between tilting your head and moving in a straight line, which is a critical distinction. So you've got all this info flooding in from your eyes, your body, your inner ear. So how on earth does the brain decide what to pay attention to? Well, that's a process we call sensory weighting. Let's say you're standing on a wobbly surface, like sand. Your brain quickly learns, hey, the info from my feet isn't so reliable right now, and it starts to rely more heavily on your vision and your vestibular system. It's this constant adaptive process of figuring out which signal is telling the truth. All right, so let's pull all of this together. What are the big takeaways, the core architectural principles we really need to remember from all this? Okay, if you remember anything, remember these 3 things. First, the whole system is hierarchical. It builds from those super fast, simple reflexes all the way up to complex, adaptive control in the cortex. Second, the VOR and VSR, they are the non-negotiable hardware. You cannot have stable vision or posture without them. Simple as that. And third, balance is a team sport. It's multisensory. Hubs like the cerebellum are working 24/7 to mix all those signals together to create our seamless sense of equilibrium. Okay, so now that we've got a handle on the neural hardwiring, you've got to join me for video 2, the bedside battery, because that's where we'll translate all this physiology into actual clinical practice. We'll cover the specific protocols for the Romberg, tandem gait, and really get into the nuances of the Fukuda stepping test. Thanks so much for joining me for this part of this series. To explore more on dizziness, vertigo, and imbalance, or to get some great resources for both clinicians and patients, head over to AustralianDizzinessClinics.com. And of course, please subscribe and leave us a rating. It really does help.